All right, so for Newton's law of cooling, what's happening is you're talking about how long it takes for an object to cool. So it has an original temperature and then it's cooling down. So we have a couple things going on, and one of the more popular ones is one that you guys can kind of easily visualize, and that's like taking a pan out of the oven, right? You take the pan out, it's really hot, and then after so much time that pan cools down. Well, this is that formula for that. So what we have is this is the final temperature of whatever your object is. So in this case, we'll have a pizza pan, right? The T is your constant temperature of your surrounding medium. So T would be like the big T here is like your room temperature. Like that's what's happening in the room, okay? And then this U naught, that's your heated object. All right, so this is the original temperature of the heated object. This would be like your final temperature, the cool temperature, not cooled. So this is when it's so hot. You're going to take the difference of that and the room temperature, and then it's still e to the kt. So that's how it kind of ties in with the problems we did before, is you still have this constant rate of change happening, okay? Or a continuous, I should say. There's a continuous rate of change because temperature, as it cools, like it's hitting all those values of temperature as it gets cooler and cooler. All right, so here's what we have. We have our time is at 5 p.m. Okay, so this is we're going to use in our final answer at some point. So we're going to leave that alone for a while. But we have the oven whose temperature is fixed at 425 degrees Fahrenheit. Well, if you have a pan sitting in the oven at 425 degrees Fahrenheit, guess how hot the pan is. 425 degrees Fahrenheit. So this is your original temperature of the object. All right, it's going to be in whatever source it's being heated up to. Okay, so we have that first. All right, the room has a constant 73 degrees. So what does this one represent? So the temperature of the room, big T, you bet. Okay, now this is the extra information to help get our rate of change because we don't know what our constant of decay is at this point. So this is going to be our time. And then the pizza pan, after 5 minutes, the pizza pan cools to 300. So 300 is the final temperature only after 5 minutes. Okay? But what they want to know how long it takes to get to 125 degrees. Right? So it takes 5 minutes to get to 300. They want to find the time it takes for 125. Well, in order to get this, we first have to figure out what K is. So right now we have 1, 2, 3, 4, 5. We have all these variables, right? We don't know K, so we're going to use all this given information to find that. So again, you're going to want to write small. So U of 5 is 300. Our original temperature, our room temperature is 73 plus our initial pan temperature is 425 minus the temperature of the room, 73, and then that's e to the kt, but t is 5, so that's going to be e to the 5k. All right. So what are we going to do first? We need to get rid of the 73. So if I subtract the 73, we're going to get 227. And then 425 minus 73 is? So we got to subtract first in the parentheses. 352. So 352 e to the 5k. Now what? Now we divide. So then we get e to the 5k equals 227 over 352. What do we need to do next? Take the log of both sides. Now I'm going to do a shortcut here. Are you guys ready? If I take the natural log of the left-hand side, what am I left with? 5k. So I get 5k equals, and I also have to take the natural log of this side. So I just saved myself a little bit of time there. And then the final step in solving for k is to divide. So k equals the natural log of 227 over 352 over 5. Now again, whenever I find k, especially like this one, you can see how it's kind of a big number. And the rest of the problem, I'm going to be writing k, and then I'm going to do the substitution at the end, so that way I'm not constantly writing natural log of 227 over 352 divided by 5. All right, so that'll save a little bit of time. So now that we have k, now we can do this part of the problem. So we want to know, we're trying to solve for the time that it takes for the pan to get to 125. Okay, so that's going to be our final temperature. We have 125 equals, and then it's going to be 73, and then we already did this subtraction, so it's going to be plus 352E, and then I'm just going to write to the KT. Okay, so I know K though, so K here, it's a known value. All right, how do I solve? What do we do first? Subtract the 73, good. So then we get 52 equals 352 e to the KT. Next, divide. So 52 over 352 equals e to the KT. Okay, now if we take the natural log of both sides, right, the natural log of this side leaves us with, which is KT. And the natural log of this side, we would still have this, but it'll be the natural log of that quotient. And then to solve for t, we divide both sides by k. So that means t equals the natural log of 52 over 352 all over the natural log of 227 over 352 divided by 5. Okay? So that's a doozy to type in. All right. Oops. So on top, we have the natural log of, oopsies, natural log of 52 divided by 352. And on the bottom, we have another quotient. So that is the natural log of 227 divided by 352 over 5. And then you get about 22 minutes it takes, okay? So t equals 22 minutes. The thing is, though, you guys, what is the question asking? It's asking at what time? So the time it started, it was removed at 5 o'clock. So the time is 5:22 p.m. Okay, so now what we want to do is we want to determine the time it takes before the pan is 240. Okay? So how is this going to vary from this problem? What's going to be different? Yeah, instead of the 125, you're putting 240, and you're going to solve everything the same way. So we have 240 equals 73 plus 352 e to the KT. We're going to subtract 73 from both sides. So we get 167 equals 352 e to the KT. We divide. We take the natural log of both sides. So if we take the natural log of this side, we get KT. And then the natural log of the left side, we get 167 over 352. And then to solve for t, you just divide by k. So then t is the natural log of 167 over 352 over k, natural log of 227 over 352 over 5. So again, notice I'm not putting in the decimal approximation for this because if I were to round this, my answer would be different versus using all exact values until the end. So the only time you want to end is when you are getting your final answer, okay? So for this one, when you plug it in, what do you get? No. How many minutes? About 9 minutes. 8.5, so about 9 minutes. If you put 8.5 minutes, that would be fine.
Okay.
Yep.